That crunchy banana chip began as a green fruit, but inside this factory, heat transforms it completely. And what happens between harvest and that first satisfying crunch involves precision, pressure, timing, oil, and thousands of moving parts. Most people never think about this. A fragile banana must survive harvesting, transport, cutting, frying, cooling, seasoning, and packaging. One tiny change in ripeness can alter color, texture, browning, oil absorption, and the final crunch you hear. But here's what nobody tells you. The factory doesn't simply cook bananas. It carefully removes water without destroying structure. Imagine millions of thin slices passing through hot oil, each one needing nearly identical heat exposure to become perfectly crisp. Today, we're going inside that giant production line, starting where everything begins, the farms and freshly harvested bananas. By the end, you'll see exactly how an ordinary green banana becomes a golden snack sitting inside your cupboard. Banana production stretches across Asia, Latin America, and Africa, with India and China among the largest producers for domestic consumption. For exported bananas, Central and South America, plus the Philippines dominate the supply chain, moving fruit around the world. The banana chosen for chips usually stays green and firm, because ripe fruit carries more sugar and browns much faster. That firmness matters because slicing machines need clean cuts, not soft flesh that collapses under pressure. On arrival, workers first examine size, color, firmness, damage, dirt, and signs of disease before processing begins. Damaged fruit gets separated immediately because one poor quality batch can affect appearance, flavor, yield, and production efficiency. Next comes washing, where high-volume water sprays remove soil and field debris clinging to the banana surfaces. The wash area feels cold and wet, while pumps roar continuously and water rushes beneath stainless steel conveyors. After washing, workers remove unwanted ends and prepare each banana for peeling, cutting, and the next controlled transformation. Peeling sounds surprisingly simple, but at factory scale, hundreds of pieces must move continuously without bruising or contamination. Once peeled, the pale banana flesh immediately becomes vulnerable to oxidation, discoloration, and moisture changes. Some factories use water, salt, or approved food treatments to help control browning and preserve consistent appearance before frying. Then comes a cut that determines everything: thickness, shape, cooking speed, crunch, and even how much oil gets absorbed. Industrial slicing systems can produce huge volumes of uniform pieces, turning whole bananas into thin, rapidly moving streams. And here's the hidden challenge. Slices that look almost identical can still cook differently because their moisture isn't perfectly identical. That is why factories monitor incoming fruit constantly, adjusting processing conditions before a small variation becomes a large problem. From one plantation to one processing line, the supply chain already depends on timing, temperature, cleanliness, and careful handling. But the real transformation hasn't started yet, because those pale slices are still soft, wet, and completely unrecognizable. The first major transformation happens inside the fryer, where hot oil attacks surface moisture and begins building the crunch. For conventional frying, published processing studies commonly test temperatures around 160 to 180 degrees Celsius, depending on product conditions. That's roughly 320 to 356 degrees Fahrenheit, hot enough to drive water rapidly from each thin slice. As water escapes, bubbles race across the slices, steam erupts upward, and the soft fruit begins losing its flexibility. Think about this. You're watching water leave the banana while the oil simultaneously transfers heat into its starchy structure. Inside the slice, starch is softened under heat before the structure dries, stiffens, and develops a familiar crisp bite that a typical published process uses roughly 3 minutes of frying, though industrial lines tune time for cultivar and thickness. Too little time leaves moisture behind. Too much can darken the chips, harden them, and push flavor beyond the target. That's why temperature control isn't decoration. Sensors constantly watch the fryer, so the oil stays within its operating window. Large fryers also move oil continuously, helping distribute heat and prevent local hot spots from damaging individual slices. In some systems, moving mechanisms gently shake or guide slices so oil contacts them evenly during cooking. The sound changes too. Raw fruit is nearly silent, but frying produces a constant hiss of escaping moisture. Then, Almost suddenly, the slices become rigid enough to hold their shape and strong enough to crack. But they're not finished. Fresh chips still carry surface oil that must be removed quickly and consistently. Centrifugal systems can spin cooked chips while gravity and rotation pull excess oil away from their surfaces. The chips emerge lighter, drier, and ready for cooling, but their temperature remains far too high for packaging. Cooling lets heat escape while the crisp structure stabilizes, preventing condensation from ruining the texture inside the package. And this is where it gets truly extraordinary. Cooling isn't simply waiting. Airflow, time, and moisture control all matter. Once cool enough, chips enter seasoning, where tiny particles must spread across thousands of surfaces without clumping. Salt, spices, or flavor blends can enter through calibrated feeders, delivering measured amounts as the chips tumble below. Too little seasoning tastes flat. Too much overwhelms a banana, so dosing equipment works with surprisingly tight control. The finished chips now look familiar, but the factory still has one major enemy: moisture from surrounding air. Even a small amount of moisture can soften that satisfying crunch, making packaging a critical part of manufacturing. Before sealing, the line measures portions, removes foreign material, and checks appearance so only acceptable chips continue forward. Then packaging begins, often using multi-layer materials designed to block moisture, oxygen, light, and unwanted odors. Some modern packages can replace much of the internal air with protective gas, helping preserve crispness and freshness. The bag seals with sharp mechanical snap, trapping the chips inside, while conveyors immediately carry finished packs away. What started as soft green fruit has now become a stable, crunchy product ready for inspection, cartons, warehouses, and stores. Now the factory becomes a laboratory, because every batch must prove its color, weight, texture, safety, and consistency. First comes weight, where automated scales repeatedly check packages and reject anything outside the program target. A package can look perfect yet still fail weight control, so scales operate continuously rather than relying on appearance. Next, optical inspection looks for dark spots, broken pieces, unusual shapes, foreign objects, or other visible defects. High-speed cameras can inspect products far faster than human eyes, especially when thousands of pieces move every minute. Software compares each image against program quality criteria, turning appearance into measurable data instead of guesswork. When a defect appears, an automated air jet or mechanical diverter can remove the suspect product in milliseconds. But machines still need humans, especially when unusual fruit behavior doesn't match the pattern software expects. An experienced operator can notice a strange smell, unexpected color, unusual oil behavior, or texture before sensors explain why. That's a human advantage. Experience connects tiny sensory clues that don't always appear as clean numbers on a screen. Quality teams also test moisture because crispness depends heavily on keeping the finished product sufficiently dry. They may also monitor oil quality because degraded frying oil can change flavor, color, aroma, and product stability. Factories control oil temperature tightly because overheating accelerates unwanted chemical changes and can darken the finished chips. Modern lines can connect sensors, scales, cameras, and controls into one synchronized production system that creates a digital trail, letting operators trace batches backward from a package toward processing and incoming raw material. If something goes wrong, traceability helps isolate the affected production window instead of guessing across the entire factory. Packaging checks don't stop at the seal. Factories also verify print quality, coding, package integrity, and correct product information. A perfect-looking bag means nothing if its seal leaks, because oxygen and moisture can quietly destroy the crunch. Finished samples can also undergo sensory checks, where trained people evaluate crunch, aroma, flavor, color, and mouthfeel. The goal isn't merely making chips. It's making today's chips behave like yesterday's chips and tomorrow's chips. That consistency is what separates a home kitchen experiment from a modern industrial food process. And just when you think the technology has done everything, humans step back in for decisions machines still struggle to make. Bananas are one of the world's most produced, traded, and consumed fruits, with more than 1,000 varieties worldwide. The Cavendish is the most traded type, accounting for just under half of global banana production. FAO estimates annual Cavendish production around 50 million tons, an astonishing amount for one banana group alone. Global banana trade has recently hovered around 20 million tons annually, moving huge volumes across oceans. More than 90% of export bananas originate from Central and South America and the Philippines. The biggest importing markets include the European Union, United States, China, Russia, and Japan. Behind those numbers are farms, workers, truck drivers, port crews, warehouse teams, engineers, inspectors, and factory operators. A single snack therefore connects agriculture, logistics, food science, mechanical engineering, packaging technology, and global retail. Did you know banana plants face serious disease threats, including Fusarium tropical race 4, known as TR4? Let's follow one final batch from its last inspection to the moment it leaves the factory. The bags are counted, packed into cartons, stacked onto pallets, and prepared for transport. Robotic or powered pallet equipment can move finished cases quickly, keeping products organized for warehouse storage and shipping. The warehouse may look calm, but behind those boxes sits an enormous chain of controlled decisions. Every carton carries a result of farm selection, transport, cleaning, slicing, frying, cooling, seasoning, inspection, and sealing. What product you'd like to explore next? Like this video, subscribe to the channel, and we'll see you inside the next factory.